When you calculate the truth value of a complex, well-formed formula, what you do is take truth values that are assigned to the propositional letters, which is the interpretation of those propositional letters, use those truth values to determine the truth values of the subformulas in that complex, well-formed formula, and then use the truth values of those subformulas to determine the truth value of the entire complex, well-formed formula. In other words, the truth value of a complex, well-formed formula is always determined by the parts of the formula. Now, sometimes people run into difficulties. They have the truth values assigned to the P's and Q's of the formula, but they're just not quite clear or certain, or they don't feel confident about sometimes which step to take, which subformula whose value we should determine first. Okay. I'm going to give you a tip about how to do that, and this tip is related to construction of the formula. So let's look at an example because I find it easy to learn a lot of these things just through some example. Let's say we had the formula not P and Q, and we're asked to determine the truth value of this particular formula. And let's just use one assignment of truth values to P and Q. So we know that the truth value of P is true. So let's write true underneath P. So let's write true under there. And let's just say the truth value of Q is also true. Okay, now we want to determine the truth value of not P and Q. Now the first step I think is that most people get is to write the truth values that are under these letters, that is the truth values assigned to the propositional letters, under the propositional letters in the truth table. So we'd say that if P is true, then P is true in the formula. And if Q is true, then Q is true in the formula. Where people sometimes have difficulties now is, well, what do I do next? Do I take this truth value T and determine the truth value of not P and write a truth value under here? Or do I take the truth value of Q and P and write it under this sign for negation? You might not have difficulty with this one, but maybe in the process of determining some formula, you run into some issues where you are just unsure which truth values to use to take the next step in determining the truth value of the formula. So here's the tip. The tip is simply to construct the formula, because the order in which you assign truth values to the parts or the subformulas, in other words, the order in which you evaluate the formula, is the same or corresponds to the order in which you would construct or build the formula using the formation rules. Again, that's a mouthful, so let's just look at an example. My suggestion is simply to build this formula. So let's build it. So what we would say is, well, we have this formula not P and Q. We'd start by saying, well, P is a well-formed formula and Q is a well-formed formula. That would be our first step. Then what we would say is, well, since P is a well-formed formula, not P is a well-formed formula. So since P is a well-formed formula, then not P is a well-formed formula. And then our final step would be to take not P right here, see this not P here, and Q, and say, since we've established they're both formulas, we can take them and put them together and put the sign for conjunction between them. So we would say that since Q is a well-formed formula and not P is a well-formed formula, it would follow that not P and Q is a well-formed formula. All right, so remember, the order in which we assign truth values to subformulas is the same as the order in which we construct the formula. So in this case, what do? Well, we have P and Q. And so if we were trying to determine the truth value of this complex well-formed formula here, the first thing we would do is get the values for P and Q. And we have already done that here. We know that P is true and Q is true, and so we've determined the truth value of these parts, P and Q, in the formula. And we signify this by writing true and true under that P and Q in the formula. So our question then was, well, what do we do next? Do we do the not P or do we do the conjunction? Well, look at our construction. Line 2 here says, well, if P is a well-formed formula, then not P is a well-formed formula. So what this is telling us is we're going to take the truth value of P and use it to determine the truth value of not P. So our next step here, let me use a different color. Our next step here would be to take the truth value of P and use it to determine the truth value of not P. So we should try to determine the truth value of not P here. Well, if P is true, then not P will be false. And we're almost done. But we might say, well, when we're looking at this formula, well, which truth values do I use? Do I use the true under P or the false under not P? Do I use this true over here? Which ones do I use? Well, the construction gives you a clear sign of what you should do. It says that when we built the formula, not Q is a well-formed formula and not P is a well-formed formula. And so the conjunction of those two is a well-formed formula. So we're going to assign the truth value to this conjunction. And what we're going to use to do that is the truth value assigned to Q, which is right here, and the truth value assigned to not P, which is underneath this negation. So we're going to use this false and this true here to determine the conjunction. Now, a conjunction is true just in the case that both of the sides, both of the formulas it connects are true. But so since we have a false here and a true here, the truth value we'll write is false. And this false tells us that when P is true and Q is true, this entire formula, not P and Q, is false. So again, the sequence or order in which we flesh out the truth table or evaluate the formula or take the truth values that are assigned to subformulas and use those to determine the truth value of the complex well-formed formula is or follows the order in which we construct the formula.